Hello everyone, welcome to a Friday new product post video where we talk about all the new products we have for the week. We've got a lot of stuff to talk about, so let's dive right in and see what we have for this week. First up, we've got a new product from Modular Robotics. This is the MOS. Modular Robotics is the company behind the Cubelets, which are modular robotic pieces that fit together and form these various little robot contraptions. The MOS is very similar, except for this actually uses these little metal balls to connect everything together. So let me show you what it looks like. We've got the manual, and inside we have all the individual components. Here's what the actual components look like, and you can see they just have little magnets that connect everything together. So when you want to connect two pieces, you just use the magnets like that to make your connections. And this transmits the power as well as other signals that go through the components. Inside this kit, there are 7 different blocks in addition to some various connector pieces. So let's see what's inside the kit. First up, this is the battery block. You can see it has a little on and off switch, and on the back side we have a USB port for charging. The kit also comes with 2 motor modules. These actually spin like that. Now you see that there's green as well as brown little ports here. The green is power and the brown is signal. So if you wanted to get a signal to this, you would attach it to the brown and you'd attach power to the green. This blue little guy is the hub block. The hub is useful for transmitting either data or power to the various different components. So if you connect this to a green, it would transmit power, or if you connect it to the brown, it would transmit your data. The kit also includes 2 sensor modules. Here we have a light sensor and a proximity sensor. And in addition to all these different components, we have a couple connecting pieces. We've got these little arms, which connect like that. We've actually got 2 sets of those. We have these little elbow pieces, in addition to this little bridge, and another elbow piece. And then we also have a couple of wheels, and then this kind of springy connecty piece right there. And this whole kit comes with 56 of these little steel balls, which are used to connect everything together. So I put this little guy together. It's got the 2 motor drives here, it's got a proximity sensor up front, and it has the battery in the middle, and all this stuff is connected, and this is just for stability and for show. So when I turn this on, it will drive towards my hand. So this is the MOS Zombitron 1600 from Modular Robotics. This week we also have a lot of new sensors from Vernier. We have a photo gate, we have a pH, a motion detector, a temperature probe, and a gas pressure sensor. Nick is going to talk about how all these function and how these work with the Vernier Arduino Shield.
For a long time now, Vernier has been sort of a trusted name in classroom sensors for technology classes and for science classes, and you may even recognize some of these sensors that are on the table from classes that you took in middle school or high school, all the way up through college level classes. The reason that they've become such a name in schools is because they sell pre-calibrated sensors, and they basically plug and play with a variety of data collectors that they also sell. But recently we've come out with a Vernier interface shield, which allows you to connect these nice pre-calibrated sensors to your Arduino. So you can combine pre-existing science curriculum that uses these sensors with maybe new curriculum that includes data collection with Arduino or programming. So we're actually carrying a small range of their sensors to go along with our interface shield, and they've released Arduino code for all of these sensors. So starting from this side, we have a gas pressure sensor, we have a temperature probe, a motion sensor, which is actually a sonic rangefinder, a photo gate, a dual range force sensor, and finally a pH sensor. And these are pre-calibrated sensors that you can actually do real science with. I'm going to hook up a few of them to our shield here and boot up the computer and show you a few of the example sketches that are on the Vernier GitHub repository and show you how easy it is to get these sensors up and running. First up, we have this force sensor, and this is a dual range force sensor, which means that it'll measure both force pulling on this hook and force pushing against it. and it actually has two ranges. So it'll measure plus or minus 10 newtons of force, as well as plus or minus 50 newtons of force. Now these are really handy in science classes where you want to measure force, especially if you're studying something like friction, where you want to put a block on the table, hook this hook to it, and then drag it and see how much force it takes to overcome that static friction. This also comes with, you'll notice the hook can unscrew from the end of this sensor, and it comes with a little rubber bumper that you can put on there instead to measure pushing force. It also has a screw here so that you can put it on a stand, and you can hang things from it if you want to do that, or hang a spring from it and study spring forces. And I'm just going to plug it into one of our analog ports on the vernier shield. These are British Telecom connectors, and now that that's plugged in, I'm just going to go to the computer here and pull up the demo code. Now I've pulled it up in Arduino, and I'm just going to go to Tools and make sure I have the right Arduino selected, and we'll upload that to the board. And now if we open the serial monitor, you'll see that it starts spitting out values. And the rate at which it spits out these values is adjustable in the code. There are numbers appearing on the screen, and as I push on this sensor, the numbers will go up or down as I push or pull on this sensor. And right now those numbers don't relate to a real-world value in newtons. This code is generic analog sensor code. There are these two values here, slope and intercept, and then there's a sensor name here. And you can look up in their repo, they actually have a nice link here to their site where they have a table of all of the intercepts and slope values for their different sensors. So you just find the dual range force sensor in that website, and you copy those numbers in here, and then it'll spit out actual newtons of force. Next up, let's talk about the vernier motion sensor. Now they call it a motion sensor. In reality, it's a rangefinder, so it'll actually give you the distance of the nearest object to the front of the sensor here. The nice thing about this is that it's a nice solid package sensor. All of the smarts are in here, and it just spits out the information that you need straight to the shield. So it actually has a swiveling sensor head here, and it also has a 1/4-20 threaded mount on the bottom here, so you could mount this on a tripod, flip this up here, and measure things driving past it or running towards it, and gather data that way. Now to plug it into the shield, it comes with this cable, again with the British Telecom connector, and plug the other one into one of the digital ports. So we're going to go into digital 1 on the shield. Here you can see I've opened up the library again, and I'm just going to look for vernier motion detector. Open that up in Arduino, and then go to Tools again and check that I have the correct Arduino selected, and we'll upload that. This sketch will spit out distance in centimeters at a regular interval that you can adjust in the code. So we'll open the serial monitor, and you may be able to hear the motion detector actually clicking. It uses an audible sort of echolocation to determine the distance. So if I pick up the motion detector and sort of aim it down at the table, you can see that the numbers are changing on the screen. As I lower it down towards the table, the numbers get smaller. Pick it up from the table, numbers get bigger. And if I flip this over and aim it at the wall across the room here, you'll notice the numbers get much larger. And in theory, that should be real centimeters from here to the wall. Finally, let's talk about the vernier photogate. This is a great sensor for a whole lot of classic science experiments. You can set it up under a pendulum and measure the rate at the period of the pendulum swing. You can set it up at the end of a Pinewood Derby track as the finish line and get exact start and finish times for like Pinewood Derby cars, things like that. And the great thing about this photogate in particular is that it actually has a switch on the inside that you can cover this side of the photogate, and then there is another receiver in this end of the device, and you can aim any laser pointer into that to make a much larger photogate or break beam detector. First, we just connect it to the shield using this cable that comes with it. It has the sort of a phone connector on one side, and then the British Telecom connector again. And this is a digital sensor, so we'll just go into digital 1. And there's a red light on the sensor that'll turn on to let you know that it's ready. We'll open up that demo and upload that to our Arduino. Now that we've uploaded the sketch, we can open up the serial monitor, and you'll see here that it has time in milliseconds here, and this is milliseconds since the sketch was started, and then time down to microseconds here, and this is the time at which the photo gate was blocked. So what this sketch does is it basically shows you when the gate was blocked from the time that you started the sketch. And you should see that on the shield, this blue LED is off whenever the gate isn't being blocked. So when you block the gate, that light will turn on. And you'll notice as I put my hand in the gate on our sketch here, there are a series of numbers showing up that correlate to the time since the device was turned on when this was blocked. So I'm just swinging my arm back and forth in a pendulum fashion, and you can see it's actually catching the space in between all of my fingers as I go through the photo gate here. So it actually has a really quick response time. Now what I've done is I've taken one of our green laser modules and I've hooked it up to my bench power supply to give it some power, and I've clamped it up in a helping hands here just to be able to sort of focus it and adjust it around. And I've taken the photo gate and stuck it to the table here, and I have the switch covering the photo gate on the inside so that it's using this outside sensor as its primary detector. So now all I have to do is turn on my power supply, and as you can see, there's a green laser dot here. And all you have to do is line up this laser dot with the detector, and when you get the laser dot lined up, you should see the light on the shield turn off to indicate that the beam is not being broken. Now that I've got it lined up, we have a break beam sensor over this entire area. So now you'll notice when I put my hand down here, that light comes on, and it's logging the time that the beam is broken. And you can do this for any range as long as the laser is powerful enough to set off the detector on the other end. So essentially, the range of your laser pointer is your limiting factor. So that's our new line of vernier sensors. They all work with the vernier shield, and there's example code online for all of them. So make sure to pick a few of these up if you want to do home science experiments, science fair, or if you're a teacher and you want to use them in class or in your hackerspace.
And lastly, we have a new soldering iron. This is your typical kind of wand style soldering iron. It kind of fills that gap in between the really cheap fire starter, you know, just a little stick that gets hot kind of thing, and the soldering station, something like this. This one is really nice because it's actually temperature controlled. So here's what it looks like. It has a nice handle to it, and you can see that it has a little knob for temperature adjustment. The knob easily adjusts for your temperature control. You can go anywhere from about 200 up to 500 degrees, and there's even a little calibration pot inside there that you can calibrate it. There are full instructions inside on how to calibrate it, so you can go ahead and check these out. And also the iron comes with a little stand, which is right here. You just pop this out, fold this up, and you have a nice little place to rest your iron. So if you're looking for something a little bit nicer than the really cheap irons and you need some temperature adjustment, check out this guy if you don't have room or don't want to invest in one of the soldering stations.